Hi guys, my name is Rahul, and as we know that we were doing data analysis series. So in that series we have done chapter number 1, that is introduction to data analysis. Chapter number 2, that is the project overview, what we are doing today, right? I have already told you in this video what is the thing which we are going to do. Project number 3, in which I have tried to explain you what do you mean by exploratory data analysis, and I have tried to describe you different kind of charts as well. Fine. So today we will be watching data preparation, along with we will be solving this loan approval prediction in Jupyter notebook as well. So as you can see on the screen, I have opened up my Jupyter notebook. Without wasting much of a time, let's start. All right. And meanwhile, whatever we encounter like outlier treatment, one hot encoding, skewness, I will be explaining you with the keynote expression over here, in which I have explained everything. Fine. So don't worry, just watch the entire video and then we will be looking forward to it. So loan price prediction, let's start. First, we'll import some important packages like pandas as PD, numpys as NP, seaborn as SNS, matplotlib. From matplotlib, I want pyplot as PLT, and I have made it inline, and I have ignored all the warnings. So let's run this. Fine. And these are my data descriptions. Fine. So these all things I have discussed in the previous chapter, guys. So if you have not seen that, I would urge you to watch that, because this is the continuation of that. Fine. Now second is I would want to read my CSV. I'm reading my CSV from my GitHub file. So in my GitHub, you can definitely go on to this, and then you can in CSV file you can find the data set. Loan price prediction, there has to be somewhere here. It's the loan approval prediction. So you go on to raw. The Jupyter notebook will be able to read the only raw portion. So you copy the entire URL and then you paste it over here. Then it would be able to read. So df.head, I would want to read the first 5 rows of it. So loan ID, gender, married, dependent, education, self-employed, applicant income, co-applicant income, loan amount term, credit history, property area, loan status. So this all I have explained you in my previous chapter, right? So in here, rather in the second chapter, where so I was discussing about the entire thing, right? So these all things I have explained over in the chapter 2. Fine. So don't if you have not watched it, I am again asking you to watch that. So this is done. Now let's check for null values, right? So null values, syntax for null values is dot is null dot sum. So I can see there are some null values, right? So like in dependent column, there are 12 null values. In loan amount, there are 24 and so on, right? So let's check for the shape. So shape is like 598 rows and 13 columns are there for my things. Okay. So I want to see. So let's take care of the null values, right? So dependent column. So what do I want? I want the value counts. So how much values value count? See, for dependent. Now what do you mean by dependent? Dependent is it tells whether the applicant has any dependent or not. It means like is there any person who is dependent for them or not? You know, you get the picture, right? So like there are 338 people who have no dependents. There are 101 people who have one dependent, and similarly it list goes on. Like if I want to see the distribution of it, I would make the distribution like this. So I would do plt.show. So yeah, so this is how it is. So I'm not getting anything out of it, but let's just look for that. Fine. So now let's go for descriptive statistics. Like in the, I would want to transpose it. Yeah. Now, what do you mean by describe? I have already explained it in this, right? Yeah. So descriptive statistics generate summary or statistics for numerical columns, including count, mean, and quartile. So this is what it is showing. See, for dependent columns, see, there are numerical values, right? So of course, any mathematical calculation or statistical calculation which can happens only for the numerical columns, right? So that's why dependent, the describe has taken only numerical columns and counted the summary for that. Say dependent column has 586 count, which means this is what my shape is, right? So remember 598 rows were there, but still since there are 12 null values, so 598 minus 12 comes out to be 586, right? So this is how I can get there are null values as well. So that's why in the previous lectures I have told you that describe method gives you a loads and loads amount of intuitions. Like let's explore this. Okay, so from the very first entry, I got to know that it has null values as well, because I know for the first time itself that I have 598 values, but the count of dependent column is only 586, which means there are null values. What is the mean of it? 0.7593. What is the standard deviation? 1. Minimum value is 0, maximum value is 3. So you can see that from till 25% or till 50%, there is no values which is ranging. Till 75% there is 1.75 value, like, right? So which means it is skewed data. It's not evenly distributed, it is skewed data. So that's why will take care of that. Don't worry, there are more number of values which is lying on the right side of the things. That's why it is left skewed data, right? So maximum value is 3. For the same applicant income 598, there are no null values. Mean I can see 5292. Standard deviation 5807. Minimum value is 150. Maximum value is 8100, or rather 81,000. So see, from this column what I can make out? From this column what I can make out is minimum value is, let me zoom it. Yeah, I can zoom it here. See, applicant income, so minimum value is 150. 25% lies in 2877, 50% lies as 3806, 75% as 5746, around like 6,000 you can consider, and then the maximum value is 81,000. So can you see there is almost equal range between minimum and 25%, and then 25% to 50%, and then 50% to 75%, but there's a huge jump onto the maximum value, that is 81,000. Credit history, you can see maximum value and minimum value 0, so it's a boolean value, right? So that's why you can see 25% is also 1, 50% is also 1, and 75% is also 1, which means that the data is imbalanced, which we'll take care in the model building part. Fine. So loan amount term, again I can see there is like the minimum value is 12, 360, 360, 360, and then again 480, which means there is very less value between minimum and 25%, right? So this is what the intuition we can make out, right? So this is what we can make out from describe column. All right, so let's go for null values now. See, so what see in this syntax, what I have tried to do is, so what am I trying to do in dependent column is, so see, in dependent, let me run df.head. So in dependent column, so I can see there is like just now we have discussed, right? So there is like what are the value count of 0, 1, 2, 3. So since there are so many people with 0 dependent, and I can assume that they're the null values, and since the null values the count is very less, so it's very safe for me to say that I can replace the null values with 0. Now this is in this case, guys, you have to use your brain. Now that is what data analysis is. There is no predefined method. Data analysis is all about exploring. That's why it's called as exploratory data analysis. Data analysis, which means like you have to know about things. What value, why would you want to replace with only mean or median or mode, or why only, see in here I did not check for mean, median, mode also. I directly replace it with 0, because I'm assuming that there are null values. The null values are very less, and there are more like 90% of the data, or rather 75% of the data has 0 independent people. So that's why I can replace it. It's very safe for me to say that there is you can replace it with 0, right? And then since it is you can also do it like this as type. I'll just, yeah. So see, since these are numerical values, so that doesn't make sense for it to be float. So I'm changing it to int value, right? So I've changed it into int value. Let me check. See, now dependent has changed to null values, or null values has been also been removed. Let me check also. If I run this again, see, the null values has been removed, right? So this is how you remove it. Yeah, so you either replace the np.nan values, or you can fill the na values. All right, so there are multiple methods you can do it. So I have taken care of my dependent column. Let's go for the next null value, that is my loan amount, right? Loan amount. Let me check for my loan amount. Okay, so let me check for the unique values. How many? So there are very much unique values, so I do not draw any insights from this. So what I would do, I would try to draw dist plot for that again. So see, from this plot, what I can make out is a lot of data is ranging in the first half of the data, or first 75% of the data, which we have seen in the describe method as well. For loan amount data, see, there is like lot amount of data which is lying between minimum values to 75 percentage, and then from 75 to maximum you can see there is a huge jump onto it, right? So this is what the statistical analysis which it is giving, and we can confirm it from this as well. plt.show. Yeah, we can confirm this from the disk plot as well. See, there is a huge amount of data which is lying between 0 to 300, and then there is, that's why it is called as right skewed data. Where is the skewness? On the right side, right? Left skewed data. Let me check for this, right? Hist plot. Let us see hist plots. Okay. See, in this left skewed data, which means, see, can you see like there is very minute values which are present over there, which means the data distribution is skewed onto the left side. That's why it's called as left skewed data. Similarly, if I have to tell you, yeah, so here see left skewed data. So majority of data lie between in the left hand side, which is making the resultant is making to shift the data, the maximum data is stretching towards the right side. That's why it is called as right skewed data. Similarly for the left skewed data, right? And we have to take care of this, because in order for us to have a good balance between all the values, and in order to get the good accuracy, we have to take care of the skewness as well. So, and also skewness is gonna give you where are the outliers present, because outliers can be present on the left side as well and can be present in the right side as well. So remember one thing. Okay, this is a very good interview question as well. So this is a statistical statement which I want to make is mean is highly affected by outliers, which means if a column has null values and also it has outliers, then you cannot go on replace the null values with the mean, because mean is highly affected by outliers. Because that's what is mean. Mean is nothing but sum of all observation divided by number of observation. So if sum of all observation includes outliers which is huge in values or very less in values, which in turn is gonna favor the mean to shift towards the skewness, right? So that's why you can see in here, so mean is shifting towards the right side where the skewness is, right? This mean is shifting towards the right side where the skewness is, because this is where the huge values are going to be. And for the left skewed data, the mean is going to be shifting towards the lowest values, because this is the point where the minimum values are there, right? The majority values are here, but the minimum values is going to be making it partial. The mean is going to be partial towards the skewness. So that is why mean, you cannot just go on replace it with mean, right? So that's why. And one more statement I want to make, median is not affected by outliers. So what is median? Median is nothing but the middlemost values after sorting the data, right? So that's why what I can do is let's check for box plot as well. See, there are very many outliers. So you can see my most of the data is lying between 100 to say 175, and my minimum value is say 0, and my 75% you can see is somewhat around 275, right? This is for loan amount. So loan amount, my 75% is 167, right? So what is this? This is my 167, right? So this is 0, this is quartile 1, this is quartile 2, or quartile 2, and this is quartile 3, which means 0%, 25%. This middle line is my 50%, that is also my median, and this 75%, this line is 75%, which means my 75% of the data is in this corner, like 177 or 167, right? So since there are null values and there exist outliers, and we know that mean is affected by outliers, hence we can replace the null values with median. So that's what I did. I did the null values to be filled with the median, right? So I did that, and then I can do it here as well. Why did I do it in the separate cell itself? I don't know. Yeah, so I'll just comment it out. If you can see the head, let's check once more for my null values. If I run this again, see here, loan amount should be gone, like this 21 values should be replaced with the null values. We just replaced it, right? So see, after me executing this command, the loan amount has become 0, right? So this is all the mathematical calculation, guys. This you have to take care of once you started filling the null values. Filling the null values is the basic concept, and whenever you go for any data analysis interviews or anywhere, you will end up getting questions like this, right? Let's check for the loan amount term. because the next null values are there for loan amount term, right? So loan amount term, again I am checking for value counts. There are many value counts, like 360 is 500. There are 500 entries which has 360 loan amount term. 360 is the number of months, right? So loan amount term is term of loan in months, yeah. So 360 months. So there are 500 people who have taken the loan amount for 360 months, right? So again I would want to check if there are outliers. Of course there are outliers. If I want to check for the disk plot, again yes, I'm not drawing any intuition from this. So and I can see there are a lot of outliers. So what do? I have to check for the median. So median is 360, of course, because what do you mean by median? Median is the middlemost value. So if out of, see, let me check how, yeah. So if out of what was my shape was somewhere around 598, right? So out of 598 values, there are 500 values which contain 360. That majorly means that the median is also going to be 360, right? So if you want to consider mode also, mode is also 360, because what is mode is the maximum number of occurrence, right? So that's why. And what do you mean by mean? So see, mean is 341. So why? Because the, you can see, like, I can say in a layman's term that this is a left skewed data, because there are a lot of values in the left skewed. The majority of the data lies on the right side. So that's why the mean is tending towards the left side, towards the skewness of the data. So that's why it's not fair enough for me to replace the null values with mean. I can definitely replace it. So by now, by this, you can definitely see, by this you can definitely ask questions, is there the median is also same, mode is also same, why not I'm replacing it with mode? This is a special case where the mode is also equal to the median, but there will be there will be many more cases where median is not equal to mode. At that time you have to replace it with median, right? So this is what it is. So that's why I am going to replace it with median. And also I would want to change the type as type to int, right? So I replaced it with this. So let's do one thing. Let's run our df.isNull.sum. So see, now loan amount term is also done. Now let's check for credit history. Let's check for credit history. Again the same concept. I would want to check for the value counts, credit history. Like the data is very highly biased, but then again biasness will take care afterwards. And then again, now I don't want to check, I don't have to check for any outliers or anything, because since there are so many values with credit history 1, so I can simply replace it with 1. That is what I did here, right? So I did change it to 1, and also I've changed the data type to int, right? So now value counts, co-applicant. Let me see if there are co-applicant income. So yeah, so I've done everything. So I think I have not changed the co-applicant. Yeah, so co-applicant, see, now here I'm taking care of the just let me comment this out. Taking care of the data types, right? So taking care of the data types is very important, guys. Again, this will affect the accuracy, not marginally, but very very minute. But you have to, it's a good habit to take care of the data types also. It has to be in this perfect data type. So I can see in here that the co-applicant has no point values, which means I can definitely make it to the int format or in data type. So that is what I did. So this is what it is. Now if I want to check my info, or rather checking info, df.info, see, the entire thing has turned out to be int 64. So now it will be better for the machine to understand the int and the float values and all, right? Now let's check for skewness. Now again, like till now I was asking for, like I was talking to you about skewness, the data distribution, where all are the data distributed, how is the data distributed and all. Guys, it is very important for you to take care of the skewness of the data. Unless you don't take care of the skewness of the data, but the data will not the data will be biased. All right, the machine will give you the output, but the accuracy will not be as good as what you want. Okay, you have to take care of the outliers, because if the data is normally distributed, then only your accuracy will be good, then only your model performance will be good, right? So this is what it is. So if for applicant income, so let's df dot head, let's keep on checking for your data, guys, because see, this is how, like, this is your go to thing. You have to run this command again and again, data.head, because you have to see, right? So that's what. So applicant income, where is my applicant income? I want to see how my data is distributed. See, I wouldn't want loan id anyway. I'm going to drop it after, if not now, but in the later stage I'll definitely drop it, because this is not going to give me any insight. This is just the index. Gender, yes, of course I am going to do encoding for this, male and female. I have to convert it into afterwards. Married, I'm not going to do any statistical analysis. Dependent, again, this is a unique value, boolean value. Education, again, it's a boolean value. Self-employed, again, it's a boolean value. Applicant income is something which I will be worried about, because this contains numerical values and I want to see how data is distributed. So this is why, what did I do? I am plotting two plots. First, in the so PLT, I'm giving the figure size, right? And I am making two plots in the same lines, like in the same row, one row and two columns. Once I run it, you will better understand it. So this is number of rows, this is number of columns, and which plot it is. The first plot is my this plot. So this plot, sns.displot, which one? df.applicant. And I want it to be tight layout, because I'm congesting two plots, so I want it to adjust itself. So subplot, second plot would be 1 comma 2 comma 2. Number of rows is 1, number of columns is 2, and this is which plot I'm talking about, this second plot. So if I run this, you see, this is what I was talking about. The number of rows, what do you mean by rows? Number of rows is 1, number of column is 2, right? So two graphs I'm plotting. So that's why this subplot is very important. Again, interview questions. Okay, so now what you can draw, let me make the color to red here. Color to red. Yeah. So I did make the color to red. So you can definitely see in here that data is rightly skewed. See, there is like 80,000 till 81,000 the values is going, but most of the data is lying between 0 and 20,000. Right, the 75% you can see it's around 70,000. Here also you can see the data is like there are loads amount of outliers, right? So which we have to treat now. So in this, like, how do you address skewness, guys? Skewness is addressed by two methods called square root transformation and log transformation. First is square root transformation. In square root transformation, you don't do anything. You just take the square root of the entire column, right? So the square root transformation is a mathematical operation applied to individual data points in a data set. For each data points x, the square root transformation is given by root of x. It is particularly useful for addressing right skewed distribution by mitigating the impact of extreme values in the right tail. So remember one thing, whenever your data is right skewed, which means your extreme data are present on the right side, or you can also understand this by, if your outliers are on the right side, then you can definitely go for a square root transformation, and if it helps make the distribution more symmetrical. Okay? And then second is logarithm transformation. You take the log of x, right? Logarithm transformation is effective for reducing the impact of extreme values, making it suitable for both right skewed and left skewed distribution. So based on the performance, based on the skewness, if it is left skewed data, right? If it is left skewed data, you have to go for a logarithm transformation. Now, by the, like, you can definitely like try to run the errands, like try to run the calculations in your mind, guys. If I have extreme values onto the lower side of my data, say for example I have 0 1 2 3 4 5 6, and then again starting like till 200 300 400 500, I have my majority of data from 200 to 300 suppose, and there are some outliers 0 1 2 3 4, and in this case if you are taking square root of it, it is not serving the purpose. Because what does square root does is square root takes the huge value and bring it down, right? Square root of 1 is 1. Square root of 10 is 3.1 something. So highest value, if there are higher values, you have to take it down. Then if that means your data is onto the right skewed data, guys, by now I think I am hoping that you guys know what is right skewed and left skewed, because I am mentioning right skewed and left skewed so many times that I don't want you to get confused. I want you to know perfectly what is right skewed and left skewed, right? So if the data is right skewed, then definitely it's, you can make it a hard and fast rule. If the data is right skewed, go for a square root transformation. If the data is left skewed, go for logarithm transformation. And the logic, you would be able to explain it in front of the interviewer if that situation comes. So let's see how the square root transformation changes the perspective after taking the transformation or root transformation. Yeah, so see this, the data is somewhat, you can see it was so much of right skewed. Now the data is, see, you cannot get 100% normal distribution, you can get somewhere near to normal distribution. I'm not saying that there are no outliers. We still have to treat outliers, right? We have to still take care of the outliers. But then again, but you can see with this that there are the situation is much improved by this, right? So this is what it is. And let's go for co-applicant incomes. So there are again it is also right skewed data. I have taken the square root transformation of it. So see, the data is now very less skewed, right? So this is what it is, right? So this is what I just wanted to explain, guys. So I hope, like, I don't want the class, this lecture, to be very lengthy. I would want to finish it over here, guys. So what all things I have done in this lecture is, in this lecture, let's revise data preparation. Okay, let me play this. Yeah, data preparation, what we have done: data pre-processing, steps involving data cleaning, right? We have done data cleaning, we have removed all the null values. Data transformation, right, which we will be doing in the next class. Handling missing values, which we have done, taking care of the missing values, right? Mean, median, mode. Strategy is removing missing data. The cons would be reducing the data size, which may lead to the information loss. But then again, guys, you have to remove the outliers. Until and unless you don't remove the outliers, you cannot go for model building, right? So this is what it is. One different method for removing the did I mention outliers? Sorry, I mean to say missing values. Okay, null values or missing values. There is one more method to remove the missing values, is to just drop the missing values. But then again, if there are very much, like, very, if your data size, the complete data size, is very less, replacing the null values would be much better than dropping the null values. If you drop the null values, the data size will decrease. If you replace the null values, then the data size will not decrease, right? So this is what you have to take care in your mind. Strategies to handle, again, numerical column, mean, median, and mode. Remember one more observation, guys. For any numerical data or for any numerical column, if there are null values, you replace it with mean or median, depending on the situation. If there are outliers, go for median. If there are no outliers, go for mean. And if there are categorical data, so null values can be there in categorical or numerical, both the columns, right? So in both the columns, if it is a numerical, go for mean or median. If it is a categorical data, then go for mode. Okay, so that is also we are going to understand in the next. So in this playlist, you will see me solving many more data sets. The more the data sets you solve, the more concept you will be clearing in your head. So I did not check for duplicates, right? So let's check for df dot duplicates. Duplicated, rather duplicated. Yeah, so I want the sum for this. Yeah, so there are no duplicates, right? So there are no duplicates. So I'm checking for duplicates. So why drop duplicates? Duplicate value will give you false hopes. Again, duplicate values will make things like the model will learn the same thing again and again, which is useless, right? So this is what it is. Dealing with duplicate is critical aspect of data cleaning, ensuring the data set is free from the inaccuracies and bias, and that is accurately represent the phenomena that is being analyzed, right? So this is what it is: better data accuracy and integrity, improved model performance, minimization of bias and misrepresentation, better understanding of data, right? So duplicate values we have removed, right? If you want to remove, you have to drop the duplicate values. And then handling outliers, which we will be seeing in the next class, because this class has already been lengthier, which I don't want to. There are different method to take care of the outliers. In the next class, of course, we will be dealing with it. So I hope that you guys have followed me till now. So I'll meet you in the next video. Till then, I want you to take care of you. I'll meet you in the next video. Till then, take care. Bye bye.